In this video, I'll be covering question 4, part B from the 2023 AP Calculus AB No Calculator Allowed portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see those other solutions, please check out my other videos. When I see a graph on any AP Calc question, the first thing that I want to do is reinforce in my brain what this is the graph of. So we need to recognize that what we have up top here is the graph of f prime. This is the graph of our derivative. So beat that into your brain. Remember that that is the graph of the derivative. Question B is now asking us on what open intervals. So remember, when you give your intervals here, do not put brackets on it. Those are going to be parentheses because it's open intervals. They want to know on what open intervals is the graph of f, the original function, concave down. Concavity is a second derivative game. When we want to know when the graph is concave down, that would be where our second derivative is less than 0, where our second derivative is negative. Since we're looking at the graph of the derivative, what we're going to do is we're going to read our derivative information off of that. And by reading the derivative information off of that graph, we're actually getting second derivative data out of there. You were more used to this when you were working with an original function. If they told you that that graph was the original function, then wherever that graph was headed up and had a positive slope, that's where the original graph was increasing. Wherever that graph was headed down and had a negative slope, that's where the original graph was decreasing. And wherever that graph went horizontal for a second, that was a 0 slope and a 0 derivative. Well, we're going to play the same game. We're going to be looking for the ups and downs, but because our new graph that we're starting with is now the first derivative, our data that comes off of it is now going to be second derivative data, so it has a different meaning. Wherever the graph is headed up now and has a positive, this is where our graph has a positive second derivative, so it's concave up. Wherever that graph is headed down now, that's a negative second derivative, and that's where our graph would be concave down. And then wherever our graph would go horizontal, that would be a 0 second derivative, and those are possible inflection points. So we're going to be reading the first derivative information off of there, but that first derivative information is now really to be read as second derivative data. What I do now is I come over to my graph and I start reading off that information. So starting on the very left-hand side here, this is all going down. So this is all negative, 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 negative. I hit a sharp corner there, so technically that's a does not exist at the bottom. Then I go up, it's going to be positive, positive, positive through that whole space. I hit a sharp corner again, so that would be a does not exist. Then my graph is going down again, so negative, negative, negative. I hit a 0 this time at 6, and then it's going to go positive, positive, positive. What we're looking at on this one is where the graph would be concave down, and it would be concave down where we have these negative sections. So where it was decreasing would be concave down. What we would do now is we would come in and give them those intervals. So working our way through this, starting on the left-hand side here, we would be starting at -2, open intervals, so parentheses, and then it would be ending right here at 0. So close, or put an open parenthesis for 0, close off the interval is what I meant to say. Then from there, we would see that we've got concave down starting again at 4, and then ending here at 6. And then your reasoning for this is you would tell them that f prime is decreasing in these intervals. So again, we're reading off in the same way we read first derivative information, but it's giving us second derivative data. So where the first derivative is decreasing is where we have a negative second derivative. We would have gotten 2 points for this question. You would have gotten 1 point for telling them the interval. And then you would have gotten 1 point for telling them that it was when the first derivative was decreasing that we got these concave down sections. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.